Hey everyone, so I'm presenting work on behalf of Max. So actually he should be on the slides instead of me, but like somebody. Okay, so anyways, so Maximilian Lee did this great work and I'm like, unfortunately cannot be here, so I take over. So let's make it quick. In the future, I think if we want to have robots really in our everyday life and they need to be productive and so on, they need to be force aware, right? Like they need to understand like forces and so on. However, even though Disney does amazing work with respect to robotics, right, this is not the force we're talking about, right? So the force that we're talking about is of course things like this, right? So manipulating, for instance, like preparing coffees and so on, like distinguishing desired forces from undesired forces, all that kind of stuff, right? And even in our everyday life, this is important, right? So if we, for instance, want to polish the table, right, there's a certain amount of force that we want to have. If we want to like turn knobs, if we want to like press certain buttons on toasters, right, or even want to screw in the light and things like this, right? So forces are everywhere. So, however, if you actually look at the current state of simulations, right, so if you actually want to train something based on that, forces are not so great there, right? So, like, if you consider that while this looks nice, right, or actually, like, it looks more fluent, really, on my notebook, but like in this simulation, the basketball has 5 kilograms, right, which is 10 times as much as what a real basketball has. But somehow this hack is still necessary to make it look good, right? So that's clear discrepancy. So let's look to the real world instead, right? So we have forces in, as I already mentioned, in household tasks, but also forces in industry applications, right? Like for instance, assembly tasks or like sticking, like pack insertion, as annoying as this task becomes, right? But also like in toys, right? So, okay, so great, there's forces everywhere in the real world. Let's do this. But so we were thinking, let's introduce forces into movement primitives. If you don't know what movement primitives are, shame on you. Stefan is sitting right there, right? Like, so you all should know about this amazing parameterization of trajectories, right? But this talk is not about that. What we figured is like, now how do we actually evaluate that? Like, how can we actually show that we can adapt to different forces and these kind of things, right? So, because again, simulator is not the way to go here, right? So instead, we looked at the toys again, because this is how like kids learn to play, right? Or learn to interact with forces. So we looked at Lego in particular, and we decided to design this. So this is POEMPEL. What does POEMPEL mean? It's a German word that you use if you don't know what to name something that you stick into something else, right? It's like POEMPEL. So we designed this whole system with several key aspects in mind, right? It should be low cost, so it's 3D printed, very readily available, right? It allows for task repeatability. I'm going to go like mention it in a few seconds here. It like actually allows you to do force-aware manipulation because like different materials allow you to like simulate or like actually produce different kinds of resistant forces and so on, right? And you can actually see if you overturn things and so on, these kind of stuff, right? And like you can configure it very highly. So like the whole POEMPEL system as it is right now, and this is the first version, we're extending it, consists of a plug, right? So this would be this fella here, consists of a socket, right? And consists of the grid plate. And all of this, again, is designed for reproducibility. We actually have particular like angles in the 3D print that you basically can like set and can basically also publish to tell other people, okay, this is the exact setup, this is the exact configuration that we used, right? And yeah, so again, we evaluated this, and we have the grid plate, which allows you to be a little bit more specific where you position things with respect to the robot. We evaluated this also like on like the tasks learned with POEMPEL, also like on an insertion task on a socket plugging kind of task. And again, after we actually like used or designed POEMPEL, we also were able finally to evaluate the force-aware movement primitives, which were presented at ICAR, by the way. Yeah, so with this, you can actually now show that you're actually able to deal with forces in the real world instead of simulation, where forces make no sense. So with this, thank you everyone, and may the force be with you.